Alrighty, so on Friday, I had y'all working in Albert for SAT or PSAT. And I know this just says SAT, but it's either one. And so as I was thinking about it, and I was listening to some discussion in 7th period, because they actually talk to each other. And I was thinking about, they were arguing about something with trig. And you haven't seen trig since geometry. And you all came from different places. Some of you poor little souls probably took geometry in the summer, which is like the worst idea ever. And when that first started, I was highly against it, but I decided, my friend and I from Dobie decided we want to teach it because at least we had some control. Then it got so out of hand, I didn't even want my name attached to it anymore, so I don't do it anymore. Because I feel like you're not learning what you need to learn when you do that. Anyway, I'll get off my soapbox. We don't have time for that today. But, or, maybe you had a great teacher and maybe you had a great teacher and you learned a lot. Maybe you had a great teacher and you didn't learn a lot, and that's on you. Maybe you had not, so whatever. But there's some other things that we get very deep into trig in here, but not until next semester. And so I threw together kind of at the last minute, because I just decided Friday 7th period, pieces of lessons that we actually have coming up. And I'm going to, what should be a review some basic right triangle trig stuff, review special right triangle trig stuff, or just special right triangles, I'm sorry, and just a few other things. And also, not today, because I had very high expectations. I thought I would be able to get through both pages of notes and we'd have extra time. I didn't even finish the first page last period. So, and it's also because I talk too much, because I think about things along the way. But, and if some of it sticks, great, okay? And I think for some of you, and it will help you be able to do the best that you can on Wednesday. We need this stuff anyway. I will come back. I'll do a better lesson, which not flying through it so quickly. You can absolutely stop me and ask me questions. Otherwise, I'm just going to kind of plow through it and, throw stuff at you and see what sticks for Wednesday. Okay, we good on that? All right. So, trigonometric functions. Now, in geometry, you learn right triangle trig. And as far as you are concerned right now, and for right now, especially through Wednesday, you can only do trig with right triangles. Can you actually do it with other triangles? Yes. So that's kind of a lie, but you can't right now. You don't know what to do. Don't do it. Don't try, because it's not going to work. But trig functions, right? We have to have a right triangle. Trigonometry is the study of relationships among sides and angle measures in triangle. It literally means triangle measure. So we have a trigonometric ratio, which screams fraction, right? And it compares them. And we have ratios. They are also, some of them are functions, and we look at that a whole lot next semester too. The function part of that, and not so much on these tests. Okay, so what I have to have right now, I have to have a right triangle. I have a right triangle over here, okay? The only thing that this right angle does is tell me that I have a right triangle. Past that, I don't use it. I use one of the other two angles. How many degrees are in a triangle? 180. Okay, so if this is 90, then these other two have to add to give me 90, right? So they have to be acute and they have to be complementary. Now, here is what you will get on the test. This is the reference materials that they give you. If, bless your soul, you don't know that there's 180 degrees in a triangle, it tells you so right here. It even tells you there's 360 degrees in a circle. Okay, so it's there. Use the reference materials. Trig stuff, not on here though, so we have to know it, but it's not that big of a deal if you've already learned it. If you've never seen it before, that's a different story, but you've all, at least it has been presented to you. Again, whether or not you learned it, that's a whole different story. So here's my right angle. I pick one of the acute angles. It's usually easy to pick. It's either the one that's labeled or the one that they tell you to use. It's not big, anything really big there. And then we label the triangle. Now I know these are already labeled for you. Hypotenuse of a triangle, of a right triangle, it is the longest side. That is a true statement, because that's what everybody tells me when I ask what the hypotenuse is. That is a property, though. That's not the definition, because you don't have any side lengths. How do you know which one's the longest side? You don't, okay? You can't assume anything. The definition of a hypotenuse is that it is a cross from the right angle. That is what makes it the longest side, okay? So across from the right angle, that's your hypotenuse. So we're going to label it with an H. Then you have marked the angle you're using. You draw an arrow across from it. That's your opposite side. The leftover side is your adjacent side. Okay. There are 6 trig ratios. You only learned 3 in geometry. Your teacher may or may not have the other 3. It really was not necessary then. But we think of everything through the 3 that we actually already know, which are sine, cosine, and tangent. All right? This is how you abbreviate them for notation. For the love of all that is holy, they are not sin, cos, and tan. That makes you sound, don't you at least want to sound semi-intelligent? It is not sin, cos, and tan. Those are abbreviations for sine, cosine, and tangent. Here's a question for you. If you have a doctor, your doctor's name is Dr. Smith. Dr. Smith walks into the room. Do you say, "Good morning, Dr. Smith"? Do you say that? No, because then you sound a little Dur, right? Because this is an abbreviation for doctor. You don't literally pronounce what you see. Just like here, you don't literally pronounce what you see. Sorry, this is a pet peeve of mine. Does it matter for the SAT? No, but it matters for me. Don't say it. All right, so then we have an acronym that helps us set these ratios up correctly. What is that acronym? SOHCAHTOA. Very good. So in SOHCAHTOA, it's great if you know it. It only helps you if you can spell it correctly. That's how acronyms work. So SOHCAHTOA. So this tells us that the sine value is the opposite over the hypotenuse. So the sine of, what does that mean? Anybody know? It's a Greek letter. What is it? Theta? Does that sound familiar? Even if you don't know, because if I was actually doing this lesson for real with you, we'd talk about the Greek alphabet and all that stuff. We don't have time for that today. You might see some other Greek letters. If you don't know what they are and they just look weird to you, pretend like they're X. Change it to X so it doesn't confuse you. It doesn't really matter. All right, but it's theta. So, and you always have to take the sine, cosine, or tangent of an angle, and that's my angle, theta. So the sine of theta is opposite over hypotenuse. This means that cosine is adjacent over hypotenuse. This means tangent is opposite over adjacent. Does all that sound familiar? Okay, good. It should. So then we have 3 others, which I've seen in some of the practice SAT stuff, but unlike the SAT before it became digital, where they would give release tests and then like I could work through it as well, and I could see exactly the questions and that type of stuff. We can't do that with the digital one, at least not yet. So I'm going based on what reputable resources have, and I've seen a couple, but not a ton. So I'm at least going to address it. I'm going to tell you how to remember what's what. And then again, if it sticks, great. If not, it's not the end of the world, all right? The other 3 are cosecant, secant, and cotangent. They are not sic, and cot, okay? See, that makes even less sense. But you have to know, all they are reciprocals of the 3 you already know. That's why if we know 3, we know the other 3. And I've been doing this stuff longer than you've been alive, not just teaching, but also trig stuff. And with these reciprocal ones, I still always think about everything through sine, cosine, and tangent. We're going to become experts on everything that has to do with those. And then if I need to know what cosecant is, I think about its reciprocal and then go from there. Okay, so that's how I want you to look at it as well. So you have to know how they pair up. Well, sine and cosine sound like they'd be a pretty good pair, but they're not, because those are 2 of the 3 we already knew. But tangent and cotangent are. They are reciprocals of each other. So if tangent is opposite over adjacent, cotangent is adjacent over opposite. And notice in this pairing, one of them has a co in there. So in each reciprocal pair, there's only one co. Okay, and that's what I mean by that. So when I look at cosine, and I have to decide if it's supposed to go with cosecant or secant, if there's only one co in each pair, it has to go with secant, and secant is hypotenuse over adjacent. All right, and then cosecant will go with sine, and this would be hypotenuse over opposite. Okay, so at no point, even when we get real deep in the woods with sine, cosine, and tangent, do you have to just no cosecant. In my brain, go cosecant. Cosecant's a reciprocal of sine. What do I need to know? What do I know about sine? And then go from there and like kind of translate it back, that sort of thing. Everybody okay with all that? So not only do we have opposite over hypotenuse and hypotenuse over opposite, But because they are reciprocals, then we can also define them like this. The cosecant of theta, what does cosecant get paired with? Sine, okay? So cosecant theta is the same as 1 over sine theta. And then secant is the same as 1 over cosine theta. And cosine is 1 over theta. Okay. Everybody okay with that? We good? All right. So not only do you get those reference materials, you also get a calculator for the entire test. Now, because I used some old notes that I had and I left in this example, I kind of wish I had changed it, but I didn't. But that's okay, because maybe you get some with weird numbers, maybe you don't, but you got a calculator. So I think y'all are pretty good at manipulating the calculator to kind of match answer choices and that sort of thing if you needed to. So we're not going to go through the rationalizing of the denominator and things like that here, which we will later on down the road. But because remember on the AP exam, you don't get a calculator the whole time. So you do have to know how to do those things by hand. But here we will. So we'll just not worry about the simplifying part of it so much. I'm looking for the exact values of these 6 trig functions of theta. So here's my angle. The first thing I always label is my hypotenuse, which is across from the right angle. Then across from the angle I'm using is the opposite side. The last one is the adjacent. So sine of theta from SOHCAHTOA, sine is what over what? Opposite over hypotenuse. So 4 over 4 square roots of 5. Okay, which we're not even going to bother going through the reducing process of that. You could always, put that in the calculator, put the answer choices in the calculator, see which one match if you need to do that. We'll talk about what to do with it. But if you know what to do and you can do it correctly, that's fine too. Just not going to get into it. Cosine is adjacent over hypotenuse, so that is 8 over 4 times the square root of 5. Tangent of theta is opposite over adjacent, so that's 4 over 8. That one won't break my brain to reduce. That's 1/2. And chances are pretty good you're not going to be asked for all 6, okay? But we're going to do all 6. And so you do your, if I only wanted cosecant, if that's what they asked me for, what is the cosecant of theta? I would find sine, and then I would do cosecant, or at least know to do hypotenuse over opposite. All it is the reciprocal of this, which would be 4 square roots of 5 over 4. Now I feel like I can reduce that one without breaking my brain either. The 4's cancel out. I really just have the square root of 5. Which means secant would be 4 square roots of 5 over 8, which I could reduce to the square root of 5 over 8. I'm sorry, no, square root of 5 over 4, because you want to actually reduce and not make up math. And then the reciprocal of 1/2 is 2. Okay. Everybody good with that? Easy enough? That's just setting up the ratios, knowing how things are all related to each other. All right, so on number 5, maybe they don't give me a triangle. Maybe they give me one of the trig values and I'm supposed to figure out everything else. So in this case, I would draw a picture. Okay, I'm going to draw my triangle. It does not matter how you draw your right triangle. I would draw a right triangle. I'm a creature of habit. I draw mine the exact same way, I think, every single time. And here's my right angle. I'm going to put theta down here, but I could put it up there. Wouldn't matter. And then I'm going to label my sides. So this is the hypotenuse. This is the opposite. And this is the adjacent. Okay. From SOHCAHTOA, tangent is what over what? Opposite over adjacent. So if I have 7 over 24, opposite over adjacent. Now, do I know for sure that those were the side lengths of the triangle? No, but this is all about ratios. And once I find, nobody asked me what the actual side length of the triangle was. It's some ratio of that or some multiple of that, and it's good enough. And so with that, I know this is 7 over 24 because they gave it to me. And this would be 24 over 7, which would most likely not be what they're actually asking me for. If I need to find the hypotenuse, what would I do? How do you find the missing side of a right triangle? You know the answer to this. Think way back to like 5th grade. Pythagorean theorem, yes. So be 7 squared plus 24 squared equals h squared. And yeah, those are big numbers, but remember you have a calculator, or if you know your Pythagorean triples, once you do your thing, you're going to get that h is equal to 25. In the interest of time, I'm just going to tell you that's what you get, and I'm going to trust that we understand how to do the Pythagorean theorem, which is also on these tests. So now that I have that and the other 4. Am I good with that? They could also ask you, well, I'll get to that later. I'm going to make a note of what I want to do. Okay. All right, so we're going to use this little blank part over here. Actually, I'm going to do something, I'm sorry. Like, something occurred to me last period. Oh, I need to talk about that too. So right here, we're just going to redraw the triangle that we have, okay? And just label the 7, 24, 25, okay? Instead of using this angle, I'm going to call that angle x, so I don't throw it off by using other letters right now. And then let's say, instead of wanting the sine of theta, the cosine of theta, and then we're not going to use this space, so you can use this space up here. I want the sine of x and the cosine of x. Okay. So from this angle, this is still the hypotenuse. But now that I'm using this other angle up here, this is the opposite side, this is the adjacent side, right? Notice that the labels from the two triangles, all that happened was opposite and adjacent flipped because we're using the other angle, right? So from using this, so not theta, but x, sine of x would be opposite, which is 24, over hypotenuse, which is 25, and cosine would be 7 over 25. Now look at that compared to what we wrote in the little boxes. Do you see some similarities and some differences there? Since all that happened is we changed which was the opposite and which was the adjacent because we changed the angle, the only difference between sine and cosine is the opposite and adjacent part. So the sine of theta is the same as the cosine of x, the other angle. And the sine of, or the cosine of theta is the same as the sine of the other angle. Remember, those angles are complementary. So even if they gave me nothing else, if all they said was this, sine of theta is 7 over 25. And without doing any other work, and then they said, all right, well then what is the cosine of x? Even without finding this side length here, the cosine of the other angle would have to be the sine of the angle that we started with. You see how that works there? Okay, that's a good relationship to know. And we'll get to an example of that in just a minute. So now we're going to use this blank space to do an example that I've seen on this stuff here. So we're going to draw a triangle. I'm going to use the same numbers as that one, but we're doing something a little bit different here. And so I'm going to label it this way, 7, 24, 25. And this is triangle A, B, C. Okay. So then we're going to be told that triangle ABC and triangle RST, what does that little symbol in the middle of those two mean? It's not equal. It means similar, okay? So that's similar. This is similar. This is equal. This is congruent, right? Just to review our symbols here. So congruent means that they're exact same size and shape. That has to do with figures. Equal has to do with numbers. So that's why you kind of put these two together. But similar means that they're proportional. Okay? So they're proportional. And we're going to abbreviate here. Perimeter of triangle RST is half triangle ABC. I'm not going to make, I don't want to have to be writing forever, but I couldn't decide which examples to do before I had to copy these. So, and then what I want to find the sine of angle T. Okay? Sine of angle T is what I'm looking for. So what I would do on this question is I would draw myself a picture. And so if the perimeter of RST is half this perimeter, then it's a smaller triangle. You're drawing these pictures for yourself. Whether it actually looks smaller, completely irrelevant. So draw it where you can actually label things. Don't draw tiny things. So we're going to draw a triangle. Here's what we need to remember about similarity. So we're also kind of reviewing some similarity stuff, which is definitely on there. If these two triangles are similar, the order and the way you name these triangles totally matters. In this triangle, if B is the right angle and it's in the middle, then S has to be the right angle here. And if you are able to draw the triangles, I would just draw them turned the same way. And if this is ABC, then this would be RST. Does that make sense to you? And if the perimeter is half the perimeter of this one, that means your similarity ratio is 1/2. So all the side lengths would be 1/2. So this one would be, so if this is 24, this will be 12, because this is how similar triangles work, right? This would be 7/2, which is 3.5, but it makes my skin crawl. I'll tell you why in a minute. And then this is 25/2, which is actually 12.5. Now, because you have a calculator, using 12.5 and 3.5 are absolutely fine, but I feel like I can't move on unless we actually talk about how to do it without a calculator, because you don't always get one on other things. So here's the angle that I'm looking at, angle T. This is the hypotenuse, this is the opposite side, this is the adjacent. Now I know before I start that since it's sine, I only need opposite and hypotenuse, but it is good practice to always label all three sides, because if your label's wrong, if you get all three of them in there, sometimes you then go, wait, something's not right. So it's okay that we're not using adjacent, but it's kind of good that we have everything labeled. So to find that, I apologize if you're already out of room, we'll just cram it down here. The sine of T is equal to the opposite over the hypotenuse. Now, again, you have a calculator, so you want to put 3.5 over 12.5, type it in, that's fine. But I'm going to make you do it this way for today. We're going to do 7/2 over 25/2. I encourage you on Wednesday, if you have a calculator, use the calculator, it's fine. But I also want to remind you that fractions are not the devil. If you didn't have a calculator, decimals would be terrible here, because you'd have to do lots of long division. So this really just means division. You keep change flip, 7/2. Instead of divide, we're going to multiply, and then we take the reciprocal, and then look what happens. Those cancel out, and you get 7/25. That's faster than actually using the calculator anyway. Do you see this number anywhere else in the question that we did before it? It's right here, right? Because here's the thing about trig. Every triangle that has the same angle measures will have the same trig ratios. So if I have, or same side lengths, anything that is similar. So since they were similar triangles, their trig ratios are actually going to be the same. So the sine of angle T is going to be the same as the sine of angle C, okay, which is really what we did from the very beginning. That's what this question is testing. If you don't understand, I did it this way though, because I don't think any of you are trig experts at this point. Even if you were really good at it when you did it in geometry, you don't have a lot of experience. Like there wasn't a whole lot of practice, and it's been a while. So there's nothing wrong with doing all of this and using your similar triangles, but then when you get this, don't assume that you're wrong, because it really would have just been the same. Okay? We okay with that? We good? Okay, so now we can flip it over. And you have this big blank space here, and we are going to cut this into fourths about. You don't have to measure anything, just get about halfway this way and about halfway this way, so we can do 4 examples and you'll have plenty of room for all that. Okay, so in this first, we're going to say they give us that the sine of x degrees equals 5/7. Then what is the cosine of 90 minus x degrees? I find it strange how they write the x degrees, because usually it's like of an. Is somebody not? Okay. When they do knock, I don't hear them, and when they don't, I hear things. There's a pretty good chance some of you might just know the answer. If not, draw yourself a picture, okay? And while I say that, you cannot use markers on the tables on Wednesday, but they will give you a sheet of paper, a scratch paper, and they'll have plenty of pencils and stuff for you. If I remember the instructions correctly, it says give each student 1 piece of scratch paper. That doesn't mean you only get 1. For whatever reason, they're only allowed to give you 1 at a time. So don't try and ration your sheet of paper. Draw all over it, ask for more paper. Draw all over it, ask for more paper. Like, do what you need to do. Don't try and cram things and you can't find stuff. Like, you will have what you need, but you might have to ask for it. All right, so we're going to draw ourselves a picture. And again, like I said, I'm kind of a creature of habit. My triangles almost always look the same. Here's my right angle. And here's usually where I put the angle I'm dealing with, just because I just do them the same every time. And then if that's my angle, this is the hypotenuse, this is opposite, and this is adjacent. Just labeling all of them. And they have told me that the sine of this angle is 5/7. I know from SOHCAHTOA, sine is opposite over hypotenuse, so this is 5, this is 7. I'm not going to do Pythagorean theorem just for the sake of doing Pythagorean theorem, because I may not need it. If you understand how these triangles work, 180 degrees, this takes up 90 of it. That means these 2 angles have to add to give me what? 90. So if this is x, isn't this 90 minus x? That make sense? So this is the angle that they're asking me for. They're asking me for the cosine of this angle right here. If that's my angle, then this is the opposite and this is the adjacent, right? So the cosine of that angle, adjacent over hypotenuse, is 5/7. See how there's like not any work there at all? But if you don't label it, you're going to be lost. When I'm using x, all of these labels here are for x. The 90 minus x is this angle right here. That would make this still the hypotenuse, but this the opposite and this the adjacent. So that's where I get 5/7 from. Okay? Okay with that? Now, if I do anything up here and you're like, holy crap, that makes no sense, I'm never going to remember any of that, it's okay, take a deep breath. The next example is going to be totally different, okay? Because I'm going to hit on a whole lot of things. And you might not even get to a question like this, or that might not be the question that is chosen for you to show that you understand this. Remember, this is an adaptive test. So what I'm not really going over with you is the other stuff that before it gets here, which is like Pythagorean theorem and similar triangles and congruent triangles and whatnot. But if you get to these, I want you to be able to at least try and reason through them. Maybe you could at least knock off some answer choices. Who knows? All right, so now draw this triangle here. Let's say they give me this. And it says to find x. Really find the value of x, because I know you can figure out where it is. But so this is solving the right triangles. And I'm going to start off the same way I've started off on everything else. Here's my angle. This is the hypotenuse. this is the opposite, this is the adjacent. And just like I said before, I'm not necessarily using all three sides. I'm looking for x, so I have to use the opposite. They gave me the adjacent, so I have to use this one. I don't care about the hypotenuse. So I can just mark it out, or you can just leave it, but it's not a bad idea to always have them all done. Okay, so I am working with opposite and adjacent. Which trig function uses opposite and adjacent? Tangent, very good. And if you feel like that's halfway a guess for you, write down SOHCAHTOA. If you already turned back in the piece of paper, had it on a minute ago, write it down again. Won't hurt you. All right, so we're using tangent. So I set up my tangent stuff. I have the tangent, and it's always sine, cosine, or tangent of an angle. So tangent of 40 equals the opposite, which is x, over adjacent, which is 12. Okay? Now, tangent of 40. That's just a number, some value. You're not expected to know it off the top of your head. Nobody does. Well, there might be some people, but we're not those people. And that's just some number. So I have some number equals a variable divided by a number. What do I do to get x by itself? Multiply by 12. So I get x equals 12 times the tangent of 40. Now, it is possible that your answer choices look something like that. How do you set it up? There it is. But if it's an actual like decimal, let's first of all talk about reasonableness of an answer, because this can help you with a couple of things just in general. I know that since this is across from the 90-degree angle, that this is the largest side, the hypotenuse. We know that for sure. Now, I don't have to figure out what I'm about to ask you to work this question, just kind of taking you a little side trip here. If this is 40 degrees, what does this angle measure? 50, right? Because I have to add to give me 90. So one of the things that you should have learned in geometry is that in a triangle, longest sides across from the biggest angle, smallest sides across from the smallest angle. That's why in a right triangle, the 90-degree angle has to be the biggest angle, so this has to be the biggest side. So if these are my other two angles, which number should be bigger, x or 12? What do you think? 12, right? Because 12 is across from 50, x is across from 40. So when I figure out x should be a number less than 12. You with me on that? And if you are running out of time or you don't remember what to do next, maybe that'll help you knock off some answer choices and then you could just guess between two. That's not our goal, but we can do what we have to do. Okay, so here's the thing with this calculator. This is the Desmos calculator. It is the one that is used for PSAT and SAT. I put that link in Canvas for you. I found a description of each of the calculators, like what kind of modes are set, what's default, and what it says for this calculator is that the default mode is degrees. When I opened this up, and I hadn't done anything with it yet, I went over to the settings, and it might be now because I messed with it last period, but it was not on degrees by default, okay? You can be asked questions on this exam in degrees and radians. We'll talk about radians some tomorrow. But before you do anything trig-like, it doesn't matter for anything else you do, but any trig you type in, hit the little settings thing and make sure it's on whichever one you want. We want it on degrees, so I'm gonna make sure it's on degrees, okay? And it's on degrees, and then I'm gonna come over here and I'm just gonna type in exactly what we had there. 12, there we go. 12 times, and then for tangent, you're just typing in the abbreviation, open my parentheses, that was 40. Why isn't this working? Oh, there we go. Tangent of 40, and even before I hit enter, there's my answer. 10.069. Does that seem like a reasonable answer based on what we just talked about? I think it is. So x is equal to 10.069. And that's a little bit less than 12. The fact that these two angle measures are kind of close in measurement means these two numbers should be kind of close. Like this one should definitely be smaller, but it's not like it's 2 or something like that. All right, so that's definitely geometry, triangle, trig. We're good on that? Questions? All right, let's talk about special right triangles. Now, You know, everybody has their own opinion about how special right triangles should be taught. I have a very strong opinion about it. And I have no clue how y'all were taught. You could have been taught multiple different ways, all right? Some teachers teach it with the ratios all having X in them. I think that's a terrible idea. The ratio or the reference materials you have, this is where the special right triangle stuff is. They give you X with one of them and S with the other, which I don't know why. I don't understand the mix of that. Anyway, when I teach this, what I think the best way is that these have L's and these have S's, but here's what I want you to do. Now, you can't actually write on this because it's digital, but if you have something with a special right triangle and you're going to use these ratios that we're about to talk about, then this one I would leave alone, but this one that has X's in it, I would change everything to an S. Now, one bad thing about the S's is sometimes they look like 5s. And I know sometimes my S's look like 5s. If you know your S's sometimes look like 5s, be very careful when you go through this, okay? Now, the reason X is bad, just so you know, it's not just an opinion thing, but it could be that, I don't know, you're asked to find this missing side and in the question, this side is labeled X. Well, if it's labeled X and you're supposed to find it, and then it's X squared of 3 here, it can all get very confusing, okay? Rarely do you use S, mainly because it looks like a 5, but it is what it is. So here, and these are flipped around from what's up there, but it doesn't really matter. In a 30, 60, 90 triangle, and that's how we refer to it, a 30, 60, 90 triangle, you have, we know we have a hypotenuse. We also have a short leg and a long leg. The short leg would be across from which angle, do you think? The 30, okay? 30 is the smallest angle. This would be my short leg. So that's going to be S, not 5. The hypotenuse is 2S, and the other leg is S square root of 3. In a 45, 45, 90 triangle, it can also be referred to as an isosceles right triangle. Okay, isosceles right triangle. They're the same thing. It is a right triangle, at least two sides congruent. That makes it isosceles. So they're just the same thing. But because those two are congruent, here's where this would be an S. S, hypotenuse is S times the square root of 2. So the good news is you don't have to remember where they go and what the actual numbers on them are because it's on the reference materials. I would just highly suggest that you change this to S's instead of X's. Okay. All right. So let's see how we're going to use this. So we're going to break this into 2 also. Oh, and by the way, I know we still have 2 blanks up here, but that's because we're going to come back up here and do special right triangle examples because I had more of those than I had room for. Okay. So if it says, here's our question. The diagonal of a square, okay, and I'm abbreviating so we're not writing for days, is 7 square root of 2. What is the perimeter of the square? Okay. You understand what my words mean here? So I highly suggest that you draw a picture. I always suggest that you draw a picture. So we're going to draw a square. Is a square a rectangle? Yes. What makes it more special than a rectangle? All the sides are congruent, okay? And we have right angles. We don't have to label all that necessarily. But it tells us that our diagonal is 7 square root of 2. So when you draw in the diagonal of the square, look what you get. You get an isosceles right triangle. Since this is an isosceles right triangle, that makes both of these 45. It's fine that we don't label them, but we know that this relationship is true. So this is the side length, this is the side length, this is the side length times the square root of 2, which that totally looks more like a 5 than an S, but again, know your own handwriting and you should hopefully be okay. So because I've labeled all of this, what is S? 7. See how easy that is? This is 7, this is 7. They didn't give you the formula for the perimeter of a square, but you don't need one because how do you find the perimeter of anything? Add them all up. So that's really just 4 times 7. What is that? 28. Do you see how it's really all about labeling? It's not necessarily about the work or anything else that you are doing there. All right, so we're going to stop here today. I got this one done last period, so somebody's going to have to remind me where we got to. Okay.